Thank you all for joining us today. I think it's turning out to be a good day. Lots of good information. Excellent. I'm Jim Pung. I'm in the Windows and Devices group on the Strategy and Ecosystem team. I've been with Microsoft a little over 18 years. And in those 18 years, I've worked primarily with you partners, which has been exciting. I really appreciate that, and I appreciate all the hard work that you guys do. I'd also like to mention that tomorrow we have 2 lab sessions, one in the morning, one in the afternoon. So if you have any questions from today's session, come there. We have a great V team. They're very helpful. So come join us. I'd like to give a quick shout out to my V team. Thank you all for the help in putting this deck together, for the lab sessions. We're excited to meet all of you in those sessions. So the purpose of today's session is to illustrate all the changes to Dev Center, the fall creators update to support DCHU. We'll walk through the process of submissions for an extension INF. That's one of the hottest topics right now, right? Okay. How to best flight these drivers, and then we'll root cause Dev Center submissions in the event there is a rejection. So before I move on to the next slide, I want to prepare you. I want to make sure I have your attention. We're going to have a little fun. Y'all awake? All right. I love it. So this is going to involve your participation. How many Windows 10 drivers are on Woo? Now, this isn't really a difficult question, but it may be surprising the answer. Let's see. I want to see how many of you get it right. So I'll prep you a little bit. Windows 10 has been out a little over 2 years. It's running on over 500 million devices. I think it's good to keep in mind 500 million devices for answering this question. So you ready? Okay, raise your hands. How many of you think it's 725,000 drivers? Wow, not too many. Okay. Let's go on. 550,000. That's a few more. That's pretty good. Okay, let's go with the last one, 95,000 drivers. Wow, that equals out about the same as the 550. That's pretty good. So you might be surprised. 550,000 drivers are on Woo today, supporting Windows 10 OS for the past 2 years. You know what? This effort is all you. Thank you for all your hard support. These are drivers you've posted on Woo that support our ecosystem. That's just awesome work. I'm going to do something crazy. Give yourself a hand. Come on. Thank you. Okay, let's get a little bit into the quality. What we can do to improve that. That's a lot of drivers to maintain. So our servicing and publishing effort, it's linear to the individual number of partners that need to support those. For example, a single IHV graphics driver has over 100 submissions to support it. 100. That's crazy, one driver. And that's managed by you, our IHV, our OEMs, our ODMs. Thank you, but we'd like to make that easier. As the driver issues occur on these drivers, guess what? We need updates. So blue screens, performance issues, underlying bugs that get exposed by new feature updates. My slides are magically changing down here, so sorry for the interruption. So as these issues occur and we need a new driver, that's going to require 100 new submissions by all of you. That seems like a real inefficient use of resources and time. So in spring of WinHEC last year, we talked to you about Universal Driver Model, DCHU. We've got a declarative driver. It's INF based only. It installs on all Windows 10 editions, and it has a clean install, uninstall. Componentized. Now this is really key and a cornerstone for what we're going to be talking about today. We're going to reduce the base driver fragmentation and provide agility for the fixes that we create. HSAs, so in the store. Enhance our OS reliability, isolate the impact of apps, and support those through the store. Universal APIs. This means we can have a single driver, think of that, a single driver that'll work across all Windows 10 editions. So as we move forward, all Windows 10 editions can be supported by the driver you build. So we believe universal drivers will make it easier to maintain the quality and the end user experience. Don't you all want a great experience? I mean, this is something that we need to push hard on because we're going to have good quality drivers if we write them in this format. And our end users will be excited about it. I know they will. So let's talk about that problem I brought up a little earlier, the graphics driver. How do we solve that issue? A key pillar, componentization, where we have the base driver and an extension driver. A lot of you have had questions around this. You know, we're going to go into details here about what a base driver is, what an extension driver is. A base driver is composed of the core functionality in a single package and is generically targeted. Independently serviced, extensions are compatible with the base. They always need to be. The other two key elements for DCHU are extension drivers with hardware support apps, the HSAs. Extension drivers provide the customization, distribute in their own package, specifically targetable, independently serviced, and they work on all editions of the Windows 10 OS. So last time we talked about universal drivers and how to write one. Today, we will cover DCHU driver publishing and the servicing workflow. So there's two scenarios here. One, the base driver. The second, the base driver and the extensions. The two scenarios for publishing DCHU drivers are the same publishing method we use today for base. There's no changes. So you've got a base driver, no extension, same today as it was yesterday. The second scenario, you have a base driver and an extension. In this scenario, there are two options for submitting the extension driver. The IHV provides the extension template, and the OEM creates the extension. They do that independently. The path for publishing extension INFs is our preferred approach. And I think you'll see why as we frame this. In this scenario, there are two submissions to Dev Center. One for the base of the base driver, and one for the template, the extension. For certification, the extensions, the template, and the base should be run against the HLK together. So that means you need the extension and the base together with the HLK to get a certification. So you use those logs to post those drivers individually. So these will now be posted, well, they're certified together, they're posted individually. So what's the remaining process? The OEM publishes the resold extension, and they have to perform the following actions first. They must update their extension, create the OEM-specific extension ID, and adjust the hardware targeting. Now they can publish the extension driver. Hopefully that's a simple process. It's a mouthful. There we go. So the creation of the extension driver can also be completed by the OEM. In this case, the IHV does not need to perform any actions around the extension driver. Instead, they only manage the base driver. The OEM would therefore treat the extension as a completely individual driver, custom driver. In doing so, they would need to run the HLK against the extension, include the IHV's base driver if they want to get it certified. So extension plus base certification. The OEM would be responsible for the certification, submission, and publishing of that driver. Now that drivers are published, let's review how targeting and ranking work on extension drivers. This is a critical piece because if you get this wrong, we might have drivers overwritten. We don't like that. I don't think you like that. Base drivers are targeted and ranked the same today. No changes. Base drivers. Unlike base drivers, where hardware specificity is used in ranking, the extension INFs are ranked based on the date and version. That means a 2-part hardware ID extension could be installed over a 4-part. Not a good thing. We don't want that to happen, right? So what we need to do is we need to use specific targeting. So if you have a 2-part hardware ID, it has a newer version than a 4-part, it'll override it. So if you use specific targeting, it won't. Okay, let's move on. Change gears, let's talk a little bit about Dev Center. Is all still awake? Let's start by creating a shipping label. Discuss the universal checks, posting your public symbols, new SHA 256 certificates, our flighting process, and how to utilize the flighting analysis. I'm really excited about this change, and I hope you'll find this is very, very, very helpful. All right, already positive feedback out there. That's great. In creating a new shipping label, under the shipping label, you can now provide access to make visible to all the partners you want to have access to. Now the shipping label can be updated by all of those partners, which is going to make it for a much more efficient collaboration. Anybody out there use this? It's already live. Oh, a few hands. That's great. Now that you know it's there, how many are going to use it? All right, good, good, good. Thanks, guys. Okay. Automated declarative and universal checks. In support of universal drives on Dev Center, we've been implementing auto checks for declarative, INF, and universal APIs for validation for each submission. The new INF and API validator will be run against the Spring Creators update and later driver submissions. This includes both the HLK and the attestation certification paths. Now the results will be checked against and stored with the catalog file. So now you can go reference it and you can see the catalog file and see what the status is. You will see the D and U status for each driver, and that can be tracked for future reference. Previously, if you select the universal driver, the radial button, your driver would fail either the API or INF checks, which would mean your submission would fail. Not good. Now the results of the checks will be stored in a signed catalog file so that D and U status for the driver can be tracked. Results will be displayed under the UI in the certification section. Also, they are included in the logo verification report. So a check mark, see the check mark here? Declarative. So now you'll see when it passes, there's a check mark saying this INF has passed. And then you'll get an X if you get a failure. If the universal API is grayed out, like in this example right here, it's kind of faint, but you can kind of see it. The API is grayed out, and there's no binaries, only the INF. So that means this is just a base driver. Publishing, we will continue to allow partners to self-attest if their drivers should be published to Windows 10s, and we will re-examine these publishing rules for the future. Dev Center. Again, I call out, you guys are great help. I want you to continue that way because this is going to help the ecosystem a great deal. Public symbols. One of the easiest ways for our partners to provide a huge positive impact to our ecosystem. Please include your public symbols in every driver submission. A little detail you may not be aware of, but we found that 0%, that's 0% of crashes have been fixed without symbols. Hopefully that's not surprising. Now Dev Center will prompt for these. If there are no symbols in the submission, you'll get a prompt saying, please provide them. These symbols are used for augmenting the crash data that we do for our telemetry. We share with you this telemetry on the Hardware Dev Center, but these symbols are not distributed anywhere. We just use these for our internal use, not distributed anywhere else, so you can feel safe in sharing them. I think we'd all like to resolve those issues quicker, and this will help to that end. Update your hardware dev center certificates to SHA 256. Post February 2018, your driver submissions will be rejected if they are not. Previous submissions will not be impacted, so you're good for all the ones that you currently have. There are no required changes to the certificate or signed binaries. We have been working hard to improve flighting, so let's move on and talk a little bit about that. But notice you can go to the certification blog down here for any additional help that you might need. Flighting. Our team has been working really hard on the background to improve our flighting and our SLA. We've put together some results from February to November this year, to the first week of November. 25% of flights already meet a one-day SLA, which we think is pretty great. 68% are meeting a 7-day SLA. And 92% are meeting our 14-day SLA. The next version of Windows, the SLA is heading in the right direction, and we'll keep with the 14-day and look for improvements. And then the following update, we'll raise the bar and we'll look for the 7-day SLA. So let's talk about how we can work together to improve the existing SLA for the next OS release. Driver flighting and quality. So there are two main reasons for rejections that we've seen to date. Just two. So not a lot of work here. Just realize correcting these two small items can help our ecosystem and our SLA. So the two main reasons are targeting the down-level OS with Windows 10, with those Windows 10 OS drivers. Don't want to do that. And two-part hardware IDs without CHIDs. Don't want a two-part driver without CHID targeting. Land on the wrong box. We don't want that. Correcting these two targeting issues will reduce the rejected submissions and improve our SLA, which is a benefit to all of us and our partners and our customers. So if a driver submission is rejected, what can we do? We have new flighting reports. Dev Center flight analysis. And let's look at one of these. Understand the report and determine what the impact of those failures are. Use this information and your failures to improve the driver health. You can reproduce the problem with the tools in the HLK. So we've done some further analysis with our PMP problem codes and have provided suggested links to available test cases to help you reproduce these failures. You can understand the installation and post-installation failures. Use the failure code section of the flight report to look at the test to reproduce. So we have CM problem codes down here. These line up with the table over here and give you specific guidance on how you can reproduce the issue you found and fix the problem that you had. So this is all mapped in the docs link that we have for you. So read through this doc and you will see that there's a one-to-one mapping for these problem codes to the device error messages. And that should help move more quickly through your failures and understand what they are and how to fix those. And you can reference the WDK for more information. Healthy drivers. Begin with the existing tools to create quality drivers. That will prevent failures on Dev Center. Use all the tools. We have the code analysis tool, the static verifier tool, and then run with driver verifier enabled. These will assist in finding problems before you're ever submitting to Dev Center. The other key to having a great driver is real-world validation. So our customers have all these devices that have been updated, and if you do the real-world validation, you're going to find additional issues that you wouldn't have found before. Microsoft has a blended approach. We use the validation techniques and flighting. We encourage our partners to leverage flighting capabilities as it represents what the users have in the real world. Additionally, it enables the experience across feature OS updates. So let's get validation across all the new OS updates. There's a greater diversity for the hardware and the scenarios. And this will connect to your customer issues in the real world. I'm a little ahead on the program here, but we're doing good. Build DCHU drivers. Customize with extension INFs. Join us in the DCHU labs for day 2. Remember, there's one in the morning, there's one in the afternoon. Use the development tools that we've provided you to write your great drivers. The code analysis, driver verifier, static driver verifier, the HLK, the WDK. Use the new SysFun test tools in the HLK. The more of you that join the Insiders program, the more help we have. This is a broad set of devices. It'll help the ecosystem in all the testing efforts. So you can also get your colleagues to join. It doesn't have to be just you. Any of your colleagues can join the Insiders program. Use flighting for real-world validation. Want to know more? So we hope we're listening. We're looking for more of your feedback so you can help us even further. As we help Windows hardware ecosystem transition to universal drivers, it is important that we provide our partners with the right guidance and the right tools to write those quality software and drivers. We've received a lot of feedback to date on our documentation and would like to share some changes that we've made with the teams that we've been working on these documents. If you have suggestions to make, that's what we're looking for here, for the Windows 10 developer content, please help us. All of your documentation is now on GitHub, which makes it easy to propose a change or make a comment. So your feedback can be easily applied here. Want to know how to provide that feedback? There's a video here at the bottom. We've provided a link. Go watch this video. It'll help you with how the feedback is going to be taken. Universal driver development resources. This is a pretty comprehensive list. Now, I know our teams out there, and our V team is sitting out there. They've all contributed to these docs. They've worked hard to get them updated, to make them as useful and helpful as possible. And you can still provide feedback on these. You can start with the link in the corner down here, as it'll give you a base link to universal drivers. But all of these are key to building a great driver. So I want to thank all of you for your time, your effort in supporting us to build great drivers. So thank you very much. That concludes my talk for today.